So today's class we are going to analyze systems in equilibrium, right? And this is the particular question we are going to use in doing this analysis. Okay. So the question goes by: a fish crane has a mass of 1,000 kg and is used to lift a 2,400 kilogram crate. It is held in place by a pin at A and a rocker at B. The center of gravity of the crane is located at G. Determine the component of the reaction at A and B. Okay, respectively. Okay. So to do this, the first thing we need to know is to understand the various reactions, right? So let's look at the reaction at A, which of course we know that is what is a pin support. And this is what we need to understand by pin support. Anytime we have the pin support, we are saying that pin support what allow only rotation. That means that there's no reaction or there's no opposition. So we have a force. So it doesn't allow movement in what? In the x direction. Why? Because there is a reaction that is opposing it in the x direction. Okay. Similarly, it does not allow movement in the what? Y direction. So there is a reaction in the y direction. Okay. Now let's look at the reaction at B. In the B reaction, we have what? A roller, which is more or less like what? A car tie. It allows movement in this manner and that manner, but doesn't allow movement in the downward manner. So that means that there is a reaction that is opposing it. So we can call that reaction what? B what? Y, because it's in the right direction. Right. So after we've known this, the next thing we are going to do is to draw our free body diagram, right? So let's look at A. So we have A here. A, there's a reaction, right? So we can call that reaction what? AX. And there is a reaction in the Y manner, which is what? AY. After that, we also have what? B. And in B, the distance from B to A is what? 1.5 what? Meters, right? And then there is a force that is attached to A. So in between A and B, so let me draw them together like this. Okay, so I can draw it this way. And I will say that there is a force acting at the center. And that force is a gravitational force, right? Acting downward this way. And I can see that that force, that gravitational force, is moving in the y manner, right? And it is what? G, which is of course the mass of it is given to us as what? 1,000 kilograms. 1,000 converting to force will be what? 1,000 times 9.181. So times 9.81. That will give us a resulting value of what? 9.81 uh, kilonewton, right? Okay. Now let's look at the force that is also acting this way. So that the force is also acting downward. We can say the force is what? 2,400 kilogram times what? 9.8, because it's also affected by what? Gravitational force. That will give us what? A resulting value of what? 23 point what? 5 kilowatt newton. Okay. So this is all we have here. Now the next thing we will do is to what? Is to find the reaction. And in finding the reaction, all what we need to do is that we can state that under equilibrium position, we can say the sum of forces in the x direction should be equal to what? 0. So let's start adding them. So we have forces acting in A in the x manner, right? That is what? AX. Very good. Now we have another what? Force, right? Is there any other force acting in the other direction? Is there any other force? We have a ruler support. And I said the ruler support what? It was acting this way. That means that the force will be acting perpendicular to it. And we can call that one what? BX, right? So we can have AS plus what? BX is now equal to what? Is now equal to 0. Okay. Do we have any of these components? No, we don't have AS, we don't have BS, so we cannot proceed in finding the values. Now let's move on to the summation of what? Now, there's something we should also look at. We can say that anytime our force is moving this way is what? Positive. But when it is moving in the opposite manner, it's negative. Okay. The upward force, we are going to say that if it is moving upward, it's positive. But if it is moving downwards, then it is going to be negative. Okay. So the summation of forces in the what? Y direction should also be equal to what? 0. So let's look at it. We have AY, right? Acting upward, that means it's positive, right? Then we have what? Another force, which is this one, acting downward, which is what? Negative, right? minus 9.81, and then we have this one too acting what downward, minus 23.5. Okay, so because they are all in kilogram, that is why I didn't write the prefixes attached to it. So all these will be equal to what? 0. So it means that we can get our AY. AY will be equal to the summation of these two, which will give us a resulting value of what? Let me see, for downward down. So this will give us what? 23 point what? 56 what? Kilonewton. Okay. Now, what is next, right? What are we going to consider next? Right, we realize that we still have what? AX and BX here. So to find this, we need to find ways and means to do that. So we can also take moment at a certain point, right? So we look at what we are looking for and where there are more forces and find the moment so that all of them will go to 0 for us to get to our solution, right? So we can take moment about what? A, right? If we take moment about A, because this reaction has what? 0 distance, all of them will not produce any distance. So moment at A, so this force, the distance from here to here, moment at A is the same as the moment at B, right? Because like more or less like the distance wise, okay? So the distance is 2 meters from here, and then from here to here is also what? 4 meters, right? So moment is what? A force times perpendicular distance. So we can see what? The summation of what? Moment about A should be equal to 0. So I can do it this way. Okay. So let's proceed and do that. Okay. So now we have Bx is producing a moment. The force is here and the perpendicular distance is 1.5. So Bx times what? 1.5. Okay. And then this one is also producing a moment, which is what? Plus what? 9.81. Is it plus? Okay. It is moving what? Clockwise manner, right? So this one, realize that this one was moving anti-clockwise. Can you see that? That is why it is positive. But this one is moving down. It's moving down. So that means it's going to go clockwise manner. So that will give us what? Negative. So minus what? 9 point what? 81 times what? The 2 meters. And then this one is also moving down. So clockwise. So minus 23 point what? 5, right? Times the distance, which is what? 4 plus 2. That will give us what? 6. This should be equal to 0, right? Okay. So we can do them together. So we have 1.5 what? Bx equal. We can add this and this together and send it to the other side, which will give us what? 160.62. So we divide here by 1.5, here by 1.5. So our Bs will give us a resulting value of what? 100 and what? 60, right? 160 point what? Sorry, that will give us a resulting value of 107, right? 107.1 what? 8, right? Okay. So that is Bs. So if you want to find As, right, you just have to replace that one here. So if Bs is equal to this, then we can see that what? Ax plus Bs, which is this, plus 107 point what? 18 should be equal to 0. That means that As is also equal to what? Negative of what? Minus 107 point what? 18 kilonewton. Don't forget about that. Okay, so that is all for today. Sorry, computation wise, the value of A1 is what? 3.5. Okay, so positive. That means that's why it's moving what? Anti-clockwise. Okay, bye.